All right, our next speaker is Professor Brian Scassellati from Yale University, where he's a professor in computer science, mechanical engineering, and cognitive science. He was the former director of the NSF expedition on socially assistive robotics. He's a AAAI fellow, and he tells me that he has very much a mental health care focus. So looking forward to hearing about your work, Brian.
Thanks, Alice. So I think we've all seen robots that are in the 3Ds, dirty, dull, and dangerous spaces. And about 25 years ago, we started thinking about robots that maybe were not traditional. They were not really designed to support physical tasks, but rather were designed to support some type of social or cognitive task. Today, we call these systems socially assistive robots. And we've seen application in a wide variety of different areas, from dementia care to rehabilitation, especially stroke rehabilitation, autism therapy, anxiety, and depression, just to name a few. And all along the way, we've had to focus on a set of issues that were somewhat non-traditional in robotics. We did have to be in the wild, like many systems do, and we had to deal with very sensitive data in many cases, like many medical robotic systems do. But we also had to worry about being deployed in human-based environments over months and years, and being able to personalize what we were doing to the behavior of individual users. And these represented a wide new range of challenges for us. Now, we didn't get there overnight. But looking back, it's remarkable how quickly we did move from 15 years ago to today. Now, 20 years ago, 15 years ago, we mostly designed systems that existed only in well-controlled environments, like the laboratory. We had systems that relied on external sensing, that relied on large amounts of external compute. We looked at the way that people responded to just that one robot, that sort of dyadic representation. And we were worried primarily just about, do they like it? But over the years, we've been able to go from this well-controlled, well-specified environment to going out into medium-scale environments like the classroom, where we had some control over what was going on. We could introduce more sensing into the robot, but still have some based in the environment, where we could operate over a scale of days, not hours, and where we could try to actually solve behavioral problems, to provide training in one way or another. Today, we're actually working primarily in real user homes. And that kind of wild, uncontrolled environment is a brand new frontier for us. We're working with systems where we send out and replicate dozens or even sometimes hundreds of systems to test multiple users, multiple families all at once. We're dealing with systems that adapt and change over time so that no two systems by the second day of deployment look the same. And we're watching these systems over weeks and months. And to see this happen over just a 20-year span was somewhat incredible for us. Now, I've worked a lot with robots for education. We've taught everything from nutrition to first graders, to teaching third graders about how to deal with bullies, teaching second graders about language skills, teaching math to fifth graders, even teaching 6-month-old deaf infants about sign language. But the work I'm most proud of is actually the work that's happened in the space of autism therapy. Over the last 20 years, we've seen this go from a very niche sort of idea, where just a few of us, Kirsten Dautenhahn, Hideki Kozuma, and a few of us were putting robots together with just a few children and seeing some unusual and strange results, to now taking to the point where we're taken seriously by the people who are actually doing clinical research within this domain, where we see people seeking out robots to take over these important roles, where we understand not only why it is that the machine is actually successful in this case, but also that we're able to provide realistic therapy over weeks and months. I want to show you just a little bit of what that looks like. This was from a study that we did just about 5 years ago now, in which we put 30 robots into 30 homes. And when we did that, it was the first of its kind. Because for 30 days, these robots did social skills training, the same kinds of things that a therapist would do, actually in the home with a family. And we turned what was a tedious and difficult task for the family into something that they enjoyed. These robots played the role of a therapist. They acted to keep the therapy going. They played lots of different games that children with autism might need. And along the way, we did this in an environment that was probably the most hazardous conditions we could imagine. Many people in my place, we would rather build things for Mars than we would for a child's bedroom. We at least know somewhat what to expect about Mars. But this kind of autonomy required a lot of infrastructure. And as we built more and more of these systems, we realized how much machine learning was going to take its role, but how, in fact, worrying that might be. And trying to understand this trade-off between systems that adapted to the user and systems that had to maintain within some strict boundaries what it was capable of doing. To show you what it looked like at the end, here's one family between the beginning of the session and the end of the month. And we saw that each of these families, while they each got something slightly different out of it, all of them saw advancements in the social behavior of these children. You can see in this simple video the difference between day 3, where all of the attention is focused on the screen, versus day 27, where it's back and forth with the grandmother. Now, I've been privileged to be around for the very beginning of this field. And in fact, because this term, socially assistive robotics, only came into use in 2005, we can easily trace the number of publications being used under this domain. And for us in 15 years to go from nearly nothing to about 700 published papers a year, I think is the start of something really interesting. But just to end, there's even one more benefit that comes from this kind of work. While in more physical tasks, you might end up with very practical systems that go out into the world and accomplish that physical task. Here in the social and cognitive world, when we see successes, it's often not only that we get to produce these devices, but also that we learn something about humans along the way. That along the way, we've learned much more about how it is that people discriminate between what is an object and what is an agent. We've learned that some of the things that we relied upon in psychology and the cognitive sciences were in fact not very good metrics to use at all. And we've learned a lot about the way that embodiment actually affects people. Why is it that having a physical robot is important when I could do the same thing on a screen? So I invite you to come and learn more about this, and also to help us take this very, very young field and make it one more step better. Thanks very much.
Any question for Brian? If not? So Brian's.
Hello. Can
Hi.
you comment on the research on dementia patient care in this area?
Sure. So much of this work is not designed to, just to be very blunt in the beginning, it's not designed to cure dementia. We're not going to do anything in that respect. But a lot of it is focused on actually supporting the family, the caregivers around the individual, to make it more comfortable for that individual, to provide good safety standards for them. And there's been a lot of really fantastic work here in the robotics community from as early as 1994, 1995 or so. We know that this is a burgeoning problem that's, we don't have the human resources to solve. And so we're looking to see ways in which the technology can actually help support people who are dealing with this on a family-by-family level.
Thank you.
Sure, thank you.
Thank you, Brian.
Exactly.